Okay, so bismillahirrahmanirrahim. Sebelum kita start, kita tunggu sekejap. Kurang satu saat saja ni. Okay. Okay. Oh. Sekejap. Okay. Boleh dengarkan suara? Okay. So hari ni kita akan belajar mengenai topik rate of reaction. So sebelum kita start, saya nak ucapkan masa tak terlambat lagi. Okay? Kita nak ucapkan, saya nak ucapkan selamat menyambut bulan Ramadan. Okay. Semoga kita pada bulan ni, so kita cuba menuju ke arah kebaikan lebih lagi. Alright. Okay. So hari ni topik yang cikgu nak ajarkan ialah topik rate of reaction, iaitu topik form 5. So topik form 5 ni ada iaitu chapter 1 lah. Okay, chapter 1. Okay, so kita tengok. So, jadi semua dah ready kan? So kita boleh mulalah. So dalam rate of reaction ni form 5, so, dalam chapter 1 ni, rasanya mesti kamu semua dah belajar, betul tak? So, kita akan go through balik one by one. Mana yang sempat tu, kita akan go through. Dan kita akan cuba buat beberapa latihan sikit lah. Okay, dalam topik rate of reaction ni, cikgu nak tanya, kita kena tahu apa tu rate of reaction. Okay. Dalam, okay, kat sini ada bagi tahu tanya, what is rate of reaction? So, dalam rate of reaction ni, iaitu kita boleh cakap the rate of reaction is defined as the amount of a reactant used up or the amount of product obtained per unit time. So, actually dalam rate of reaction ni kita tahu kadar tindak balas dalam bahasa Melayu lah. So, kita ada formula dia juga. Macam mana kita nak dapatkan formula dia? Daripada definition ni. Okay. So, rate of reaction amount of ini hilang. Rate of reaction is equals to amount amount of reactant used up. So this is ni kat sini, amount of reactant used up per unit time. So ni over time, okay? Over time. So amount of reactant used up per unit time. Okay. So ni aku punya tulisan ni sangat besar. So tak apa, guna saja from definition ni, iaitu the rate of reaction is defined as amount of reactant used up per unit time. Or we can say the amount of product obtained over time taken. Alright? Okay, boleh? So dalam how we want to find the rate of reaction, method of measuring reaction rate. So we can have five steps. So the first one, we can using volume of gas produced. Okay, so the volume of gas produced, this one. Okay, yang second one is formation of precipitate. Third one, changes in the mass or concentration of reactant or product. Fourth one is changes in color. And the last one is changes in mass of the reaction. Right? So basically, if the question asks you, okay, kalau if the question asks you in your final exam or your test or any question they ask you, if they ask you what is the rate of reaction, basically you can use from the formula. So you know that the amount of reactant over time taken or the amount of product obtained over time taken. Okay, so senang kan? So jadi macam mana nak buat rate of reaction ni? Kalau dia dah bagi ni, kalau satu markah 1 mark, so confirm lah kamu boleh dapat. Okay. So seterusnya, okay. So dalam rate of reaction, so we can divide it into two parts, which is faster reaction and slower reaction. So dekat bawah ni, cikgu masih tak sorting lagi. So jom kita try buat, right? So faster reaction ni macam mana? Faster reaction ni benda yang cepat lah. Kalau slower reaction ni lambat dia punya reaction, ada tindak balas dia. Okay, so kalau air rasa ni, so agak-agak air rasa ni berada di faster reaction ke ataupun slower reaction? So agak-agak apa dia kalau air rasa ni? So air rasa ni contohnya kamu ada besi, so biasanya kalau kamu ada besi kamu nak nak rasting pun take time kan, dia lama, mengambil masa yang lama. So we can say air rasa ni slower reaction. So okay. Kalau contohlah air rasting ni biasanya kalau tahu air rasting, formula dia punya chemical equation dia. Kita kembali ke sini. So Fe Fe react with oxygen and then we can produce and then also don't forget you must have a water, okay? So you need to have oxygen, you need to have water, and then we can form a rasting equation. Okay, so later we go through about the chemical equation for air rasting, all these example. Okay, let's we sorting first. Now the second one, so we have double decomposition. So double decomposition, basically if you have silver nitrate, for example, you react with sodium chloride. So you will have a faster reaction. So you will have a faster product. So we can say the double decomposition is faster reaction. Okay. Alright. Second one. So next one we have fermentation of glucose solution. So fermentation of glucose solution is faster reaction or slower reaction? Biasanya fermentation ni kita ambil masa yang lama juga. Kita nak proses which is like you have a glucose and then from that and then we can form lah fermentation punya ni. So we can say the fermentation of glucose solution is slow reaction. Okay, and then how about the photosynthesis? Photosynthesis also is slower reaction. Okay, and then how about the combustion? The combustion macam you burn something, right? So you have for example, you have any organic compound. Last time we have learned about organic compound, right? Methane, ethane, so all those organic compound, and then you burn with the oxygen. So straight away you have you can form the carbon dioxide and water. So the combustion is faster reaction. Okay, now the last one, neutralization. So how about the neutralization? So for example, you have neutralization basically if you have acid react with alkaline. Okay, right. So that one, the neutralization is a faster reaction. So for example, like if you have sulfuric acid H2CO4 or react with any alkali which is like sodium hydroxide, so we can form the product. Okay. So now you have sorting all these example of reaction, which is slower reaction and faster reaction. Okay, so you have to know what is their chemical equation. Okay, so for example, let's we go through this one. Okay, we will go through this chemical equation. Okay, so from here, just now you have know what is the slower reaction, what is the faster reaction. So fast. So we go through this one. So the fast reaction, we know that neutralization, double decomposition, and combustion. So I give you example. So you have to practice. You have to master your chemical equation. Okay. So basically, if we have a neutralization process, so hydrochloric acid react with sodium hydroxide, and then we can form a product which is sodium chloride. So let me erase this one. Hydrochloric acid react with sodium hydroxide, and then we can form sodium chloride plus with water. And then you have to check, are they balanced or not? Okay. So we can check the hydrogen. So 2 on the product, the reactant, we also have a 2 here. Okay, and then how about the sodium? Balance already, chlorine also balance, and also oxygen. So this is our chemical equation. So the next one, this is a neutralization. Neutral. So how about double decomposition? So double decomposition. So for example, we have silver nitrate, okay, react with sodium chloride. So and then we can form what? So we can form silver chloride plus with sodium nitrate. Okay, are they balanced or not? So we have to check how many oxygen left and right must be balanced. Okay, so they are balanced already. So now the last one is combustion. So for the combustion, so we have learned organic compound for our during our first class. So CH4. So what is CH4? C stands for the one carbon, right? For me, this is a methane. And then you burn with oxygen. So automatically you will form CO2 plus with H2O. Okay, are they balanced or not? So they are not balanced because you have hydrogen 4 here on the left side, but here for the right side you have 2, then I have to put 2 here. Okay, so my hydrogen is already balanced. How about my oxygen? Here I have on the right hand side I have oxygen, I have 4. So by here I have 2, then here I have 2. So we put 2. Okay. Okay. So this is faster reaction. Okay, now we go through about the slower reaction. So slower reaction. So we have slower reaction is iron rusting, we have fermentation of glucose solution, and also we have photosynthesis. So for slower reaction, so what is the chemical reaction? Iron react with, you must have oxygen, and also don't forget with water. And then this is a formula of fasting, Fe2O3. Okay, so this one 4, this one is 4, and then I have to put 2 here, 2 for the parent, and then how about the oxygen? So here we have 2 times 3, 6, and then plus with 1, so give us 7. So then I will put 3 here. 3 times 2, 6, and then I have 1 here, 7. And then how about hydrogen? I have 4, right? So hydrogen, I have 4 here. So now I have to put 2. So 4 for E, 3O2, 2H2O, and then we can produce 2Fe2O3.H2O. Okay, this one is iron rusting. So next one is, how about the fermentation of glucose solution? So C6H12O6 is a glucose, and then we can form C2H5OH plus with CO2. CO2. So basically, you must balance. So this is a 2. Okay, how about the photosynthesis? Last one. So for the photosynthesis, so CO2 react with H2O, and then we can form C6H12O6. So again, you must balance. Okay. Okay. So here is a chemical question about some of the example of faster reaction and slower reaction. Okay, now we go back to our slide. Okay, so for this one, okay, what is the factors affecting the rates of reaction? So basically what we have. Biasanya kita ada apa? Factor affecting the rate of reaction. So we have to consider the first one is concentration, and then particle size, temperature, okay, catalyst, and pressure. Okay, factors that are affecting the rate of reaction. Okay, so actually I want to write here, but since my besar kat sini. Tak apa. Go back to our plane. Alright. Okay. So let me stop sharing first this one. So factors that affecting the rate of creation. So we have 5, which is inflation. We have what? We have in terms of particle size. We have catalyst. We have temperature. And what we have, so basically we have pressure. Okay, pressure. So concentration, particle size, catalyst, temperature, and pressure. Okay, so for this one, if you write the kalau soalan tanya kan, write the tulis dalam write the concentration or particle size or catalyst, temperature or pressure in term in kinetic theory. So you have to know the keywords. Okay, concentration, what is the keyword? Okay, particle size, what is the keyword? So try go through this one. So for, okay, let's say I took concentration. Yeah. So for concentration, what do you think? Concentration must, how we want to influence our the rate of operation? Our concentration must increase or decrease? So what do you think? So basically for the concentration, so we know that the concentration must increase, right? So how we know the concentration must increase, so our rate of reaction also can be increased. So what is their keyword if you want to write in terms of kinetic theory? So let me write here. So the keyword is when the number of ions per unit volume increase, you have to write down, okay? So when the number of per unit volume increase, and the number of ions per unit volume increase. So, okay. So our rate of reaction also can be increased. Okay. Yeah. When we can say when the concentration is increased here, when the concentration of increase, the number of ions or particles per unit volume increase. Okay. So basically, you can write down here. Let me write down. When the concentration, when the concentration increase, the number of ions or particles. So let me write. The number of particles per unit volume increase. So therefore, we can say the rate of reaction also increase. And then before you have to mention that, you need to know for the kinetic, you have to state the frequency of effective collision increase, the rate of shift increase. So basically, you have to know what is the keyword. Okay, concentration, dia punya ni, the number of particle per unit volume increase. Okay, boleh? So juga harap kamu dapat. So ni basically how do you want to write a kinetic collision theory. Okay, for the collision theory. Okay, so let me write down here. Collision theory. Here, collision theory. Okay. Okay, kalau particle size. So what do you think particle size? So particle size ni kena besar ke ataupun kena kecil ataupun small lah particle size. So untuk particle size dia punya ni, okay. So we can say when, so let me I give you example. So biasanya contoh garam. So you have kita ada garam kasar dengan garam halus, betul tak? So bila, just imagine if you have a garam halus, it dissolves. And okay, just imagine, so this is a garam halus lah. So ini, you have a garam. And then you have water. So what do you think? So which one will dissolve first? So garam halus ke ataupun garam yang kasar? Kalau particle size. So we can see garam halus yang akan, biasanya dia akan dissolve faster lah. Okay, boleh kan? Right. So kalau untuk particle size, collision theory, when the particle size, when the particle size, when the particle size decrease, so macam tadi bagi contoh tadi, so you have to, bila particle size decrease, basically we have the total surface ini besar tau. So that's why they can, the faster the rate of reaction. So when the particle size decrease, the total surface, the total so the total surface, so the total surface area increase. Okay. Therefore, the rate of reaction increase. Okay. So you have to know the keyword. So basically for the size, so macam kita bagi contoh tadi garam halus dengan garam kasar. So kalau nak buat collision theory, particle size memang kena keyword dia. When the particle size decrease, okay, the total surface area increase, then the rate of reaction also increase. So before you write that the rate of reaction, so you have the something next yang kamu kena cakap, the frequency effective collision increase. Okay, sebab dia orang akan berlanggan-langgan antara satu sama lain. Okay. Now untuk catalyst pula. So untuk catalyst pula, so biasanya catalyst ni kita ada karakter dia tau. Kita ada ciri-ciri catalyst ni. So adakah catalyst ni kena guna banyak ke ataupun kena guna sikit ke? Okay. So nanti kan kita akan tengok go through catalyst ni, ciri-ciri catalyst ni. So kita go through overall ni dulu. So what do you think? Catalyst ni kalau sebenarnya dia tak perlu guna banyak tau. Dia hanya guna sedikit pun dah kira dah okey dah. So macam mana kita nak buat for the collision theory untuk catalyst ni? Okay. So you can write down. When catalyst is used, so when catalyst is used, it will lower the activation energy. Okay. It will lower, so you have to write down it. Lower the activation. It will lower the activation energy. So and then, so bila dia dah lowerkan, dia rendahkan activation energy ni, so actually dia provide alternative jalan tau. Okay. So you can write down when catalyst is used, it will lower the activation energy. So by providing an alternative by providing an alternative. Therefore, the rate of reaction is increased. Okay. Gua harap kamu faham. Now kita baru je go through ke benda ni. Concentration, particle size, catalyst. So bila catalyst ni guna je, so kita akan it will lower the activation energy ni. And then which is you will providing alternative of path. Okay. So how about the temperature? What do you think? For the temperature, do you think they must lower temperature or increase temperature? So macam like concentration, we know that mesti tinggi lah. Kalau concentration rendah, kita punya rate of reaction pun akan jadi rendah. Okay, so for particle size, macam tadi cikgu bagi contoh lah. Garam halus dengan garam kasar, for catalyst ni pun sama. So bila kita guna sikit je, dia dah akan rendahkan activation energy, which is you akan provide alternative path. Macam dia like jalan shortcut lah, providing alternative path. Okay, dia jalan shortcut, so your rate of reaction also akan tinggi. Okay, how about temperature? Kalau temperature, so basically kamu kenalah tinggi juga. Okay, untuk sama dengan concentration lah. Okay, for the temperature, macam keyword dia kalau temperature. Okay. Okay. So bila temperature, when the temperature increase, okay, when the temperature is increased, the number of what? The number of kinetic energy is increased. Okay. So macam setiap kita punya factors ni yang involve ni, concentration, particle, dia ada keyword dia yang kamu kena tahu. Okay. So we can say that when increase temperature, so increase kinetic energy. So kinetic energy ni kamu tahu dia adalah tenaga pelanggaran, dia akan belanggar-belanggar lah. So bila temperature tinggi, kinetic energy pun tinggi. So kita punya the rate of reaction also increase. Okay. Last, untuk pressure macam mana pula? So for pressure ni, dia sama juga dengan concentration. Okay. So kamu boleh cakap when the pressure is increased, the number of particle per unit volume also increase, the rate of reaction also can be increased. So pressure kita kena tinggi lah, tak boleh lah rendah. Kalau kita punya tekanan rendah, pressure kita rendah, so kita punya rate of reaction ni dia tak boleh nak bertindak balas tau. Dia tak boleh nak cepat. Kita punya pressure ni pun kena tinggi. Okay, so lepas kamu tahu semua ni, kamu boleh tahu keyword dia ni, concentration, particle size, catalyst, temperature and pressure. So cikgu padam yang temperature ni nak ni adalah collision punya theory. Okay, kamu boleh nampak. Okay. So lepas tu kamu boleh tambah je. So the frequency of effective collision, so ni kamu tak contoh nanti. So frequency of effective the rate of reaction okay. So contohnya kalau dia suruh explain in term of collision theory, contohnya temperature. When increase temperature, or when the temperature is increased, the kinetic energy is increased, the frequency. So you have to put here. Okay, semua kena letak sini. So the frequency of effective collision increase, so the rate of reaction also increase. Okay, so frequency of effective collision ni. So kalau kamu, contoh kamu ada perbandingan, kamu nak buat rendah, so kamu punya contohnya temperature kamu kena rendah lah. So temperature jadi rendah, kinetic energy jadi rendah, frequency of effective collision jadi rendah, so the rate of reaction pun akan jadi rendah. So, jadi kalau ini cuma highlight satu je, which is biar buat semua increase so that kamu senang keyword dia. So frequency of effective collision increase. Okay, sekarang kamu boleh ambil statement ni and then kamu tahu kena keyword dia sebab kita nak buat collision theory ni biasanya sekarang 2 markah, 3 markah. So dari situ kamu kena jaga kamu punya markah lah. Kamu dah faham, so cuma kamu nak kena buat ayat je. So, cuma kamu, contohnya kamu ni kalau temperature kinetic energy. So, kalau particle size, total surface area. Okay. Kalau catalyst, the lower activation energy, dia akan provide alternative route. Concentration and pressure actually sama. So when the concentration increase or pressure increase, the number of particle per unit volume, dia akan increase lah. So and then your frequency of effective collision, again, to highlight sebab ni sangat penting. Sangat penting. Frequency of effective collision increase, so the rate of reaction pun akan jadi tinggi. So ini adalah antara faktor yang boleh melibatkan the rate of reaction lah. And then cara nak buat collision theory pun kamu dah nampak keyword dia yang penting. Okay, sekejap. So kita cuba, lepas tu kamu dah tahu contoh, example, slower reaction, faster reaction. Lepas tu chemical equation sangat penting. Okay. Kalau contohlah kalau dia minta soalan minta kamu contohnya give one example of faster reaction. So kalau 3 markah kan. Okay, kamu dah tahu kamu cerita lagi definition apa tu faster reaction. And then cuba provide contoh. So contoh tu kalau combustion, faster reaction is combustion, senang kan? So kamu ambil lah methane ke ethane ke, so bagi contoh. And then make sure balance. So kalau kamu tak balance pun no point. So, sebab tu saya buat highlight chemical equation. So, sebab tu memang penting lah. Okay, sekarang kamu tahu cara nak collision theory ni. Alright. Contohnya kalau cikgu bagi contoh. So, sebenarnya kalau untuk topik ni dia dah summary untuk kamu tau. So, lepas tu kamu kena tahu lah eksperimen yang kamu perlu tahu. Contohnya macam kalau temperature kan kita ada eksperimen dia. So, dari situ apa conclusion yang kita boleh dapat. Kalau kamu perlu buat eksperimen mengenai total surface area kan. So, apa yang conclusion yang kamu boleh dapat. Okay. So, cikgu baru teringat pasal characteristic of catalyst kan tadi cikgu nak beritahu. So, pasal characteristic of catalyst. So, for catalyst, so, So kamu tahu dia hanya perlukan only small amount needed. Okay. So only small amount is needed. Okay. Okay. And then small amount is needed pun kita dah akan increase our rate of reaction. So second one tadi kita dah belajar apa dia? It will lower the activation energy. Okay, it will lower the activation energy. Alright. So lagi apa dia? Lagi apa yang ciri-ciri catalyst? It will lower the activation energy. So lagi dari segi physical appearance dia macam mana? Adakah sama? Adakah dia akan berubah? Okay. Dari segi physical appearance dia, kita cakap physical appearance so that we can say may change at the end. At the end of the reaction. So, kalau kita punya catalyst punya physical appearance dia akan berubah lah. So, contohnya kalau kamu ada small amount of physical pieces, so mungkin dia akan jadi powder. Contoh. So, contohlah kamu masukkan catalyst small amount of pieces. So at the end of the reaction dia akan jadi powder. So how about the chemical? Ni selalu. Soalan ni kan selalu famous lah dekat exam kita tanya. So kalau dari segi chemical pula, kamu boleh cakap. So kamu boleh cakap ada chemical unchanged. So after reaction, RFN, this one is actually reaction. Okay. So kamu kena tahu. Biasanya catalyst ni kita guna bahan apa? So apa catalyst yang biasa kita guna? Kita guna apa dia? Manganese oxide. Ini contoh Okay. So lagi kita boleh guna apa? Biasanya kita akan guna copper to sulfate. SO4. So kamu pastikan kalau pastikan tulis copper to, kena mention to sulfate. Kalau soalan minta name, bila soalan minta name langsung kamu kena bagi nama lah. Bagi nama, tak boleh cakap copper sulfate. Tak dapat markah. Kita tahu copper ni dia bukan ada dua ni. Kita tahu copper ada copper 1 dan kita ada copper 2. Ini sama juga dengan ferrum. Iron kita. Ferrum tu iron kita ada iron 2, kita ada iron 3. So pastikan bila kamu tulis nama je, nama contoh ni, nama-nama apa-apa saja chemical, pastikan kamu tulis dengan betul lah. Jangan tulis copper sulfate. Dia dah salah. So, pengingat kalau cuba kamu faham ini contoh-contoh lah. Lepas tu copper sulfate. And then selain daripada tu kita pun ada catalyst kita pun banyak juga. So kamu ada iron, vanadium 5 oxide, kita ada platinum, kita ada nickel, kita ada silicon 4 oxide, aluminium oxide. Alright. So cikgu nak tunjuk contoh kalau kita buat eksperimen okay, kalau kita buat eksperimen untuk ni catalyst kita potong. So kalau untuk catalyst, kalau lepas kamu buat ni, okay, kamu dah dapat result, kamu akan draw macam ni. So kita tahu biasanya kat sini kamu akan ada volume volume of hydrogen ke sini contoh contoh. So ni after kamu punya eksperimen So, jadi volume of hydrogen ni, contoh cikgu bagi zinc. So zinc react with sulfuric acid H2SO4 and then we can produce tapi before that kamu letak ni lah catalyst kamu which is CuSO4. So ni adalah catalyst okay. Catalyst and then kamu akan produce zinc sulfate dengan hydrogen NSO4 kamu. Ni harap kamu tahu physical appearance kita akan ni Zn SO4 and then plus together with hydrogen. Okay, pastikan kamu balance lah, kamu check dah chemical equation kamu dah ni kan. Okay, after kamu buat ni, kita akan nampak perubahan lah. So ini kita akan buat perbandingan bila kamu letak catalyst ataupun kamu tak letak catalyst. So, bila kamu letak catalyst, so what do you think? Catalyst, okay, cikgu draw dulu. So kamu ada. So dekat dalam kita punya graph ni, satu ada catalyst, satu tak ada catalyst. So yang mana satu yang mana satu tak ada catalyst? So ni contoh untuk catalyst. Kita ada cuba masuk temperature, particle size, sampai. Okay. So, okay, kalau ini tadi ada dua kan? Adakah yang atas tu yang ada catalyst atau yang bawah tu ada catalyst? Okay. Jadi kalau ini, sebab kita tahu apa tu catalyst function kita. Kita tahu when catalyst is used, it will lower the activation energy and provide the alternative routes. And then we can increase the rate of reaction. So, let's say cikgu letak sini satu, sini letak dua. So, yang ada catalyst adalah nombor 2. Catalyst. So, kalau yang ni, nombor 1 ni, no catalyst. Okay, so cikgu harap kamu tahu cara kalau guna ni dari segi eksperimen lepas kamu dah buat. So, kita akan nampak perbezaan kita lah sama ada catalyst tu dia akan increase the rate of reaction. Okay. Right. So let's say kalau cikgu buat untuk temperature. Kita dah buat, so sekarang ni kita buat untuk eksperimen temperature. So kalau temperature, so macam biasa. Tengok graf kamu. Kalau adakah graf kamu yang mana yang akan, kalau kamu tahu kalau increase temperature adakah dia berada di atas ataupun dia berada di bawah. Contoh ni lah. Ini kamu punya temperature graf. So ni adalah volume. Biasakan part CY kamu adalah volume of gas. And then ni adalah kamu punya time lah. Okay. So cikgu draw ni sekejap. Ini adalah 1. So atas ni adalah 2. Cuba beritahu cikgu yang mana yang mana contoh cikgu nak faktor temperature, increase temperature lah. So increase temperature, so the rate of reaction pun akan increase kan. So jadi temperature ni, yang increase temperature kalau kamu punya graf adakah nombor 1 ataupun nombor 2. So kita boleh cakap yang nombor 1 ni adalah, contoh lah, cikgu bagi contoh yang lower temperature. Cikgu bagi contoh 30 degree. So, kalau yang nombor 2 ni lebih daripada 30 degree Celsius. Kita ambil 40 pun boleh, 5 kamu nak ambil. Contoh. So, apa definition, apa kita punya collision theory tadi? When the temperature is increased, the kinetic energy is also increased, the frequency of effect, okay, the frequency of effective collision increase, so the rate of reaction also increase. Ni kalau faktor temperature. Cikgu ambil masuk pula untuk surface area. So ni adalah contoh surface area. Contohnya kalau kamu guna zinc carbonate, so biasanya kalau carbonate kita akan dapat CO2, betul tak? Okay, so ni adalah summary recap dia. So volume of CO2 and then kamu punya time pada Cx. Ni okay, and then kamu ada lagi satu. So kat bawah ni cikgu letak 1, 2. Kita bagi satu kat tengah-tengah ni. Ini nombor 2. Atas sekali itu adalah nombor 3 lah. So, cuba bagi tahu. So, kamu ada kategori ada large, marble chip, small marble, so marble chip, and then kita ada powder marble chips. Okay, for yang mana nombor yang represent nombor 1, 2 dan 3. So we can assume this one ni adalah mass of marble is the same, okay? So mass of the marble is the same. So kalau large marble chips ni biasanya adalah nombor 1. So kalau small marble chips adalah nombor 2. Last sekali sebab kita tahu kalau powder. So, apa definition tadi? Kita dah belajar tadi. So kita ingat balik apa kita punya teori kita untuk particle size. Ini kategori particle size lah. Small, powder, large, macam tadi saya bagi contoh garam kan. So kalau particle size kamu ni, so kalau particle size decrease, which is like a powder, so the total surface area ni akan jadi besar, and then kita punya frequency effective collision increase, so the rate of reaction also akan increase. So, jadi powder ni dia kan powder, so kita punya particle size ni dah decrease lah. So tapi total surface area kita besar, and then dia akan jadi faster rate of reaction. Okay. So temperature sudah, particle size sudah, catalyst dah sudah. So kita tengok temperature dah kan tadi. Surface area pun dah sudah. Okay. Last sekali adalah concentration. Concentration. So, kalau untuk pressure, biasanya pressure ni mesti melibatkan kamu kita punya. Biasanya kita akan melibatkan kita punya gas. Okay, so jadi kalau kamu dah buat eksperimen untuk kita punya concentration, so kita anggap sini kat CY kamu mesti gas, volume, Then kita ada volume of hydrogen release. So kita ada time. Let's do. Okay. So jadi dekat sini nombor 1, nombor 2, nombor 3. Okay, kamu ada kamu nak senaraikan concentration yang ada. So kita anggap ni, so kamu ada 0.5 mol DM-3 HCl. And then we have 1.0 mol DM-3 HCl. And then kita ada 2 mol DM-3 HCl. So kita cakap sini adalah mass of magnesium and volume of hydrochloric acid keep constant. So untuk dekat graf ni, graf 1, graf 2 and graf 3. So jadi yang mana merujuk pada nombor 1, 2 dan 3. So kamu ada 0.5. Adakah nombor 3, atau nombor 2 ataupun nombor 1. Kita bercakap 0.5 ni sebab dia kan paling rendah kan, betul tak? So jadi bila paling rendah ni dia akan so jadi okey. So jadi 0.5 ni adalah kita punya graf 1. 1.0 ni adalah graf 2. Dan sebab dia concentration kan, kita tahu kalau concentration semakin tinggi, the higher the concentration, so the higher the reaction. So the faster the reaction. So graf 3 ni adalah untuk 2 mol. Okay. So sekiranya hari ni untuk topik ni, kita dah belajar pasal, kamu dah tahu apa beza, apa tu reaction, apa tu contoh example slow reaction, fast reaction, and then kita dah summary kan, sebenarnya kita dah summary kan topik ni, faktor-faktor yang terlibat untuk the rate of reaction, dan macam mana nak jawab in term of correlation theory, dan macam mana nak differentiate kita punya graph. Okay, kalau kamu diberi contoh antara between 2 mol and 1.0, so you have to know lah, so we know that the higher the concentration, the faster the rate of reaction. Okay. So cikgu harap kamu faham untuk kita punya topik the rate of reaction. So kita akan jumpa lagi. Kita akan jumpa insyaAllah. Okay. So cikgu nak kamu faham sebab biasanya topik kalau kompan ni kamu dah belajar dah bab 1 ni. Bab 1 mesti cikgu yakin semua sekolah dah habis dah. And then kamu dah masuk bab 2. Okay. Kalau kamu tak habis pun at least kamu dah dapat nampak overview dah semua ni. So which is kamu dah nampak lah, kamu dah tahu lah kalau soalan-soalan keluar ni macam senang ke ni. Senang ke nak jawab. Okay. So insyaAllah kita akan jumpa lagi. Alright. Kita akan stop sini. Bye.